27th, 2014, Renton, Washington Joint Venture Factory. I'm here with John O'Connell, Michael D'Angelo, and Shelley Shaw, and Joe Panoranda and Dave Warmanhoven just came by. John, we just put together this modular knuckle V30 support mount. Can you walk us through it and the steps it took to make it? And Michael, can you add in and point as that happens?
Okay, I can do some of it, because I worked on some of it, but as you can see, there's a lot of different pieces of it. And like some of these are basically scrap parts that we had and just kind of...
Yeah, we took a scrap bin, we took catted parts of exactly what we wanted, dimensions, and we said, well, for the first one, to know if it's even close to working, let's take scrap we have from previous iterations and see if we can mock it up, but structurally, so we can do low-speed testing, maybe 5 miles an hour. Okay, yeah, so we started with scrap, and here's a 20-inch tall tube, 6061 T6, 2 inch by 2 inches, and it's a 1/4 inch thick. And then here's 5-inch lengths here and here of the same type of tube, and then the rest is 1/4 inch thick plate scrap. And John, can you walk through a little bit about what it took to make that thing?
Okay, well, first we had, these were already cut in the previous way, so we didn't have to even mess with that. But basically we had to cut these scraps down into what dimensions based on the drawing that we had, and just make sure that everything fit in the correct spot. So we did a lot of measuring and we do a lot of, we drilled holes for all the markers where we needed them to be. So yeah, there's just a lot of measuring and drilling. We used the drill press that we had way over there.
I'll see if I can point it out there, right there, this green drill press. And that tube was cut on the red bandsaw in Seattle. But Shelley and Dave will show us in a minute these tubes they cut here on this larger green bandsaw.
So yeah, just a lot of we did take a little bit of finesse to kind of get all the bolts in the right spot that we needed them to be in. So yeah, you can see there's a lot of holes that were not used because we basically drove through just in case we wanted to use larger bolts, which we did do for the inside parts because they're much easier to bolt it together.
Whereas these you just reached in with a wrench to tighten the back, and these you tightened it by putting it all the way through bolt.
Back here it's really hard. It's like on this one as well. There's one bolt.
Yep. And now as a prototype, this is perfectly fine. But as a structural part, once we see if we like it and want to keep going, this will probably have larger bracing, maybe with another mount point further up and further up. It'll probably have bracing on both sides. This is what I'm referring to as the bracing, this piece here. It'll probably be beefier and on both sides. And probably the bolts will be exactly the right length, so they don't protrude any further than they have to. But for prototyping, this is the name of the game. Quick, dirty, fast, validate the concept or not. Michael, what might you add to that?
It's nothing to add. Just a big piece of Frankenstein, piece of art.
Right. Then would you and Shelley kindly walk us through the parts you cut today?
Yeah, we cut a couple of sections for the engine module. I think that's what that's for.
Yeah, this is 1 1/4 by 1 1/4 inch thick, tall square tube, 8th inch thick wall, 6061 T6, and that's what makes this engine module V4. So that's about 1/3 of the tubes to cut it, which is the material we had. And was there anything special about using this machine that you'd tell other people if they were going to use a similar machine?
Nothing really special. It was actually fairly simple. One thing to know is it shuts off automatically at the end. You don't have to worry about having to shut it off by yourself. If it's still running, it's because it isn't finished cutting through all the material. So we try to pick it up while it's still running and not actually finished cutting. So that's really all it is.
Sure. And now Shelley even did some grinding work, and I think I can even catch the grinding bench over here. So we did fabrication today of prototype parts. Yeah, so even took 1/8 of an inch off a part. Shelley, if someone had to tidy up a part for a clearance using a similar grinding setup, what would you tell them so that it would work well or smoothly?
Wear safety gear.
Right, absolutely. Speaking of that, could you show the holes you put in the chassis and what we learned about making part of this crush structure more compact, 19 inches tall?
Sure.
I'll follow you. So here's our test car. Yeah, Shelly, can you walk us through?
We cut this one down to 19 inches so that there would be enough clearance without having to grind down the welds.
Yeah, you can see the welds there on this version of the windshield frame, which not every car has, this version of the windshield frame, but by shortening this tube to 19 inches, we were able to avoid it, no matter what version of the current revs of windshield frames those cars are using.
Yeah, and so we measured it from the bolt here to center mass here, so you wouldn't have to worry about whether the car has this or not.
And what's that distance? 5 3/4? Yep, so 5.75 inches over from
the main.
this bolt hole to this hole, and it's on center to mount this tube. Awesomes.
And we did the same thing on the bottom, same distance.
Okay, and so this 19-inch tall tube then has a 20-inch tall tube in the rear, and that's still the same. We used to have two 20s.
Yeah.
Which is right here, and it connects to this hole and this hole, which you measured, tapped, and drilled. Thank you very much. And then this cross, after this is bolted on, and this is bolted on, this cross piece, which is 60 inches, will attach. Now these are a softer alloy of aluminum, so that their yield strength and fail strength are below the fail strength or the yield strength of the chassis, which is 6061 T6. So these are 6063. So these are side crush zones, and they mush against the side of the car on an impact. If someone had to do this somewhere in the world, measure these holes on center, what tool might you recommend, or any tip you'd give them?
Just a caliper and Sharpie.
Right? Well, that's what did it, and those are within 1/8 of an inch, which sounds really big, but for this type of large tubing is more than enough accuracy, because we're going to use a 1-inch diameter, outer diameter washer and a 3/8 bolt to hold it in. So we're able to even use hand tools in this case.
And maybe start off with a smaller drill bit and work your way bigger so that you're more accurate.
That might have even improved the accuracy further. That said, check that out. Awesome. I'll swing by the backlog and see what else we did or didn't do today. Here's today's backlog. Cut second crush structure, 19-inch, 20-inch, and 16-inch. We ran out of material before we could cut the 19-inch. Cut the front crush structure down to 19 inches so it fit. Check that the crush structure won't interfere with weld seams or wheel turning. Cut tube for more engine modules. We cut as much as we had tube. And then we drilled the V30 mount tube. That got to done. And we even bolted that together. Bolt together. There's this, cut 6-inch by 6-inch. That goes to done. Weld seat, bolt together. Oh, there's another V30 suspension on here, and I know I saw the card earlier. I'll need to make sure it gets to done so we can count our points. But folks, that's it from Renton, Washington for Sunday, July 27th, 2014.